Hello everyone, welcome to section 3.2, Finding Limits Graphically and Numerically. In section 3.1, you studied the difference between pre-calculus and calculus, and you learned that the limit process is necessary to understand many application of calculus. In this section, we are going to focus on finding limits using two methods, graphically and numerically. By the end of this section, you should learn the following. Number one, estimate limit using numerical and graphical approach. Number two, learn different ways that a limit can fail to exist. Some limits fail to exist, and we need to learn about this. Finally, study and use formal definition of limit. Let's get started. In our first example, we are going to estimate the limit numerically, but I will refer to the graph also because numerically and graphically are connected to each other. Although this example focuses on the numerical way, but I will also refer to the graphic way. Take this example. Evaluate the function f of x equals x over the square root of x plus 1 minus 1 at several points near to x equals 0, and use the results to estimate the limit. So guys, our job is to estimate the limit of this function when x approaches 0 numerically. Guys, in order to find the numerical solution of this limit function, we need to create a table of values. We need to approach the value x equals 0 one time from the left and another time from right. Look at this table. Yeah, here is the table. I place the value 0 in the middle. This is a regular table of values for x and f of x, and I put x equals 0 in the middle of the table. If you look at the values to the left, I started to approach this value 0 from the left. First of all, I decided to substitute x equals negative 0.01. This is close to 0, but if you want to get closer and closer to 0, you can choose a value less than this, negative 0.001, that's closer to 0. And if you want to get closer and closer, you choose a smaller value, negative 0.001. This is very close to 0. So in this side, we're trying to approach the value 0 from the left. Okay, and as you substitute this x values, guys, when you substitute the first value negative 0.01, you get this y value 1.999499. When you substitute a smaller value, a smaller x value closer to 0, you get this y value, and this y value is very close to what? Can you conclude something? Oh, let's wait. When we get closer to 0 and we substitute this value, we get this value. So guys, as you approach 0 from the left, the value of f of x approaches what? Yes, you are right. Approaches 2. Okay. Now, what about approaching 0 from the right? If you start choosing x values that they are close to 0 and you substitute this value 0.01, that's close to 0 but not close enough. So let's get closer and closer by substituting this, and every time you calculate the corresponding y value or f of x. Now let's get closer to 0 from the right direction, from the positive direction, and now this is the y value. Can you see, guys, as x approaches 0 from the positive direction, the y values or f of x approaches 2. Okay, so the result is the same from both sides, from the left side and from the right side. As x approaches 0, f of x approaches 2. So the limit is equal to, according to my numerical approximation, is equal to 2. And you may ask me a question. Why don't we do direct substitution? Why don't we take f of x, okay, and we find the limit of f of x when x approaches 0? My answer is, if you do direct substitution and you put 0, you will have 0 on the top, and this is not a big problem. But when you substitute this 0 down, you get square root of 0 plus 1, which is 1. And we have minus 1 outside. Guys, look at the result. It's 0 over what? Square root of 1 is 1. 1 minus 1 is equal to 0. We cannot divide by 0. Division by 0 is undefined. So don't think about direct substitution, because direct substitution leads us to undefined function. And the conclusion is, although this function is undefined at x equals 0, but this is doesn't stop from finding the limit of the function, because the limit of the function is exist and is equal to, and we verify this numerically. How do I verify this graphically? Very quickly, guys, to understand this. This is the graph of the function on the right part of this page. This is the graph of the function. Yeah. Okay. And if you study the x values from the left, and if you look at this, as x values approaches 0 from the left, the y values approaches this value, which is equal to 2. The y value here is equal to 2. And as x approaches 0 from the positive direction, from the positive direction, the y value also approaches 2. And as you see, guys, numerically and graphically, they are integrated together and they give us the same result. Look at example number 2. In example number 2, we're going to focus on finding the limit from a graph. Okay, find the limit of f of x as x approaches 2, where f is defined as, guys, we call this function a piecewise function. It's defined by more than one rule. This is what we call piecewise function. And this function is always equal to 1 except at x equals 2. It is not defined at x equals 2. And the value of the function is equal to 0. If you look at the graph, the value of the function is equal to 2 when x equal 2. Equals 0 when x equals 2. So how do I study the limit of this function? How do I find the limit of this function graphically? Guys, look at the graph of this function. The graph of this function is it's a constant function. Okay, and there is a hole in the graph of this function at x equals 2, because x doesn't equal 2 in the first part of this function. And as x values approaches 2 from the left, okay, approaches 2 from the left, the value of the function is all the time is equal to 1. And as x values approaches 2 from the positive direction, y or f of x is equal to 1. So in conclusion, I can conclude this in the following. I can write the limit, lim, abbreviation of the limit of this function f of x as x approaches 2 is always equal to 1. So now from the graph, I managed to find the limit of this function. Limit of f of x when x approaches 2 is equal to 1. Now let's see some different scenarios. In this function, limit of the function, the absolute value of x over x as x approaches 0, we need to show that this limit doesn't exist. What makes a limit doesn't exist? Actually, there are many reasons for a function to fail the limit to exist. The limit fails to exist for many reasons, and one of them, if f of x approaches different number from right side than it approaches from the right side. What do I mean? Guys, if you want to graph this function, you need to substitute some values, okay, from left and from right to the 0. If you substitute some numbers to the left of the 0, for example, if you want to get f of -2, f of -2 is equal to the absolute value of -2 over -2. Absolute value of negative 2 is 2. 2 over negative 2 simplifies negative 1. Another negative value, negative 1. F of negative 1, the absolute value of negative 1 over negative 1 simplifies negative 1. So whatever the negative value you choose, you get negative 1 all the time. So in the negative direction, as x approaches 0, the y value approaches negative 1 all the time. Okay, guys? This is the limit from the negative direction. Now we need to graph the positive direction. So let's find, for example, f of 1. F of 1 is equal to the absolute value of 1 over 1, simplifies 1. F of 2 is equal to the absolute value of 2 over 2, simplifies 1 again. And when you substitute many positive values, you will see the value of the function is always equals 1, and we represent this like this. So this is what we call a step function. It looks like a step, and the function is fluctuating between two values. The positive values gives us 1 and the negative values gives us negative 1. Okay, guys? So as x approaches 0 from the positive direction, f of x approaches 1. F of x approaches 1. So we have a problem, guys. The limit of f of x as x approaches 0 from the negative direction is equal to negative 1. But the limit of the same function f of x as x approaches 0 from the positive direction is equal to 1. Can you see that, guys? Because f of x approaches different number from the right side of 0 than it approaches from the left side, we can conclude the following. We can conclude that the limit of the absolute value of x over x when x approaches 0 doesn't exist. Does not exist, or you can just write DNE, doesn't exist. It's abbreviation of doesn't exist. So one of the reasons that makes the limit of a function fails is having different limit of the function when you approach x, when x approaches 0 from the left hand side and when x approaches 0 from the right hand side. Because we have these two different values, we can conclude the limit doesn't exist. Let's see one more scenario where the limit of the function fails to exist. Look at this, guys. This is a very famous graph. Discuss the existence of the limit of f of x 1 over x squared as x approaches 0. Guys, if you study the limit of this function, limit of f of x as x approaches 0, limit of 1 over x squared as x approaches 0 from the positive direction. Guys, look at the graph. We're gonna find the limit of this function from the graph. As x approaches 0 from the right, what happens to the y, to f of x? F of x approaches really large number, okay? It approaches infinity. As x getting smaller and smaller and approaches 0, the y value approaches infinity, and infinity is unbounded number. Okay, guys, this is what we call unbounded behavior. And if you study the behavior from the left hand side, the limit of the same function 1 over x squared as x approaches 0 from the negative direction. Look at these, guys. As x approaches 0 from the negative direction, the value of f of x approaches unlimited number, infinity. So we can conclude the following, guys. Because f of x is not approaching a real number, infinity is not a real number, not a real number. Okay, guys, and this one as well, it is not a real number. So we can conclude the following. The limit of this function f of x as x approaches 0 is, do you remember? DNE. What does it mean, DNE? Doesn't exist. Doesn't exist because, yes, they approach a value, but this value is unbounded. We don't know. It is not a real number. It has to be a real number. Okay, guys, I'll see you in the second part of this video. Thank you.